Good day everyone, today I will be discussing about the theorem on limits. Theorem number 1. The limit of k as x approaches a is equal k. So k is a constant. So take a look of that at the limit of our constant as x approaches a, and that is any number is equal to the constant. Let's solve our example number 1. The limit of negative 3 as x approaches 0, and the answer is negative 3. Okay, number 2. The limit of 2 as x approaches 5, that is equal to our constant is 2. Example number 3. The limit of 5 as x approaches negative 2 is still that is equal to the constant, which is 5. That's all. Thank you.
Limit theorem 2, the limit of x as x approaches to c is equals to c, because x is simply substituted by c as x approaches c. For example, limit of x as x approaches to 100 is simply 100, because as x gets closer to 100, the value of x simply becomes 100. Other examples is limit of x as x approaches to 58, it becomes 50. And last example is limit of x as x approaches to 28 is 20.
Hi, I'm Lian Marie Mendoza. I'll be discussing the theorem number 3, constant multiple rule. Suppose limit the function x as x approaches a is equal to L. Then we have the limit of quantity k, while here is the constant times the function x is x approach a. K is equal to the constant value of our limit, which is L. If we have our given have the constant and the function f, so we can just get the constant and multiplying to the limit of our function x. So let's have our number 1 example. The limit of 7x and approaches 1/2. So let's get the constant, and that is 7 times limit of x as x approaches 1/2. So copy the constant and get the value. 7 times 1 equals 7, and copy the 2. 8 times limit of x times approaches to 3. Let's evaluate, and 8 times 3, we get the number 3 from the approaches 3. And 8 times 3 is equals to 24. So it means 8x is approaches to 3 is equal to 24. So limit of 5x is approaches to 3. 5 times the limit of x as x approaches 3. So we have our value by getting the theorem 2, and this is equal to 5, and the limit of x as approaches 3, this is just as equal to 3. So the value of our limit is just 15. That's all the example of theorem 3.
So that's theorem number 4, sum and difference rule. Suppose limit f of x approaches to n equal L, and limit g of x approaches to n equal m. Then let's limit of f of x plus g of x approaches to n equal L plus m, or limit of f of x minus g of x approaches to n equal L minus m. So let's have example. We have limit 2x plus 4x approaches to 1. So let's separate them both. Then we have limit 2x plus limit 4. Then we have x approaches to 1 and x approaches to 1. So after that, we have to kailangan natin itong ibaba and like 2 times limit x, which is, kukunin natin to, x approaches to 1, plus, ganun din, ito kasi, kukunin natin to, which is, ito yung theorem number 1. So, magsusuppose siya ng 4. Limit 4. Kasi ito, wala na kasi, kaya ano natin siya, x approaches to 1 na siya. So, next, equal. Etong 2, bababa natin yan. And, etong limit of x approaches to 1, na nagkukunin siya sa 1 na siya kasi x to. So, 1, nagsusuppose siya ng, x, nagsusuppose siya ng 1, which is 1. Plus, kapatid natin to, 4. Equal. And this both, ita-times natin siya. So, 2 times 1 equal 2. And ito, ipakopy lang din ulit natin, plus 4 equal 6. So, we have answer 6. So, let's have pangalawang example. Gaya ng ginawa natin kanina sa number 1, eto kasi, sum siya. So, ngayon, ang example natin is yung difference. So, we have limit 2x minus 5x approaches to negative 3. Then, yung kagaya ng ginawa natin dito, isa-separate lang ulit natin yung dalawa. So, we have limit 2x approaches to negative 3 minus limit 5, negative 5x approaches to negative 3 equal, gaya ng ginawa natin ulit dito, iaano lang natin itong 2, so ibababa natin sa 2 times, and itong theorem number 3, kukunin lang ulit natin siya. Theorem number 3. Kukunin natin to, which is limit x approaches to negative 3, negative limit, ito, parang ginawa natin, aanin lang ulit natin to, itong 5, magsusuppose siya. 5. Negative 5. So, equal, gaya na, uli na ito. Parang kakopy mo lang uli siya. So, 2, negative, kukunin mo to, negative 3, negative 5, equal, 2 times negative 3, well, negative 6, negative 5, ito, kukunin mo to, ilalagay mo siya dito, and equal, negative 6 minus negative 5, well, negative 11. Kasi kapag both pag parehas sila ng both is ipagpa-plus mo siya, so kaya siya naging negative 11. So, another example pa tayo sa sum. And we have dito, limit 3x plus 6 x approaches to 1. And yun, kagaya ng neto, sundin lang uli natin yung format neto. And we have limit 3x x approaches to 1 plus, kasi nga sum, kaya plus plus, limit 6 x approaches to 1. And equal. Ano uli natin to? Kukunin uli natin itong 3 times limit x approaches to 1 plus ito uli yung theorem number 1, so 6 equal, kagaya uli ng ginawa natin dito, kunin mo uli itong n. So, 3 times 1 plus 6 equal 3 times 1, 3 plus 6 equal 9. So, we have 9. Yun.
For limit theorem 5, we have the product or multiplication rule. Suppose we have limit of f of x as x approaches c is equal to L, and limit of g of x as x approaches c is equal to m. Then, limit of f of x times g of x as x approaches c is equal to L times m. For example number 1, we have limit of x times 3x plus 1 as x approaches 2. Then, we have limit of x as x approaches 2 times limit of 3x plus 1 as x approaches 2. Then, we're going to apply limit theorem 2. So, we have 2 times, we're going to apply limit theorem 4. So, we have 3 times limit of x as x approaches 2 plus limit of 1 as x approaches 2. So, we're going to bring down 2 times 3, apply limit theorem 2, and then limit theorem 1. So we have 2 times 6 plus 1 is equal to 2 times 7 equals 14. For example number 2, let f of x is equal to 4 and g of x is equal to negative 5. Then, limit of x as x approaches c times g of x is equal to limit of x as x approaches c is equal to 4 times negative 5 is equal to 20. For example number 3, let f of x is equal to 12 and g of x is equal to 2. Then, limit of f of x as x approaches c times g of x is equal to limit of g of x as x approaches c equal 12 times 2. Therefore, our answer is 24.
Everyone, the next limit theorem we will be discussing is about the limit theorem number 6, or what we call the division theorem. So in this theorem, we should take note and always remember that our denominator here should not be equal to 0, because if our denominator will become 0, our limit will become undefined. So the limit of f of x as x approaches to c is equal to L, while the limit of g of x as x approaches to c is equals to m. Next, here, this one. Limit of f of x all over g of x as x approaches to c is equals to the limit of f of x as x approaches to c all over the limit of g of x as x approaches to c is equals to L over m, provided m does not equal to 0. Limit of 4x plus 15 all over x plus 2 as x approaches to 2. In this one, the first thing we should do is make like this. Gagawin natin siyang ganyan. Parehas nating ilalagay yung limit to numerator and to denominator. Next one, after doing this, dapat paghihiwalay-hiwalayin natin yung mga limit so that makuha natin yung kanyang maging limit. So after this, dapat paghiwalay-hiwalay na natin yung mga limit. So it will become like this. So in this one, we use the limit theorem number 3 because as we can see, may kasama yung x na number. So, gamitin na siya ng limit theorem number 3. Kaya siya naging for limit of x as x approaches to 2. And this one naman, ginamitan natin to ng limit theorem number 2, which is kapag mag-isa lang yung constant, ayun na yung magiging limit natin. So, in this one, ginawa na lang siyang 2 kasi gamitan natin siya ng limit theorem number 2 kasi ito yung kasama, this is the number where the x approaches to. Kaya, naging 2 siya. Next, in this one, ginamitan natin siya ng limit theorem number 1, which is kung ano yung magiging constant, ayun na yung magiging limit niya. So the next step we will do is that hanapin kung or i-compute yung mga na-distribute nating limit. So it will become like this. So it became 4 kasi ayun yung 4 na nasa labas. Well, gagamitan natin to limit na to na limit theorem number 2, which is kung saan nag-approach yung x, doon natin i-multiply yung sarili niya. Kaya naging 4 multiplied by 2 plus 15 all over 2 plus 2 is equals to 23 over 4. This is our limit. Next example is that if limit of f of x is equal to 4 and limit of g of x is equal to 0, this one will become the limit does not exist. Why? Because the denominator of our limit theorem and division theorem should not be equal to 0 because our limit will become undefined, or simply our limit does not exist. Next theorem, the theorem 7 or the power theorem. So still, limit of f of x is equal as x approaches to c is equal to L, and the limit of g of x as x approaches to c is equals to m. So in this one, in the power theorem, we should use this, which is the limit of quantity raised to p as x approaches to c is equals to the quantity of limit of f of x as x approaches to c raised to p is equals to L raised to p. So here's our example. The limit of 4x plus 2 raised to 2 as x approaches to 2. So in this theorem, what are we going to do is to paghiwalay-hiwalayin muna yung mga theorem and to find their limit before natin i-raise to 2. So it will become like this. So limit of 4x as x approaches to 2 plus limit of 2 as x approaches to 2 raised to 2. So after that, hihiwalayin natin yung ihiwalay or ilalabas natin yung 4 kasi ito ay limit theorem number 3. Kaya ilalabas natin yung 4. In this one, we will be using the limit theorem number 1 kasi applicable siya sa limit theorem na yon. So the next step is it will become like this. So ilalabas natin yung 4 kaya siya nandyan. Kaya magiging 4 times 2 plus 2 raised to 2. The first thing we should do is to compute what is inside in this bracket. So it will become 10. 10 raised to 2 is equals to 100. Next, the limit theorem number 8 or the radical or the root theorem. The same limit of x f of x as x approaches to c is equals to L, and the limit of g of x as x approaches to c is equals to m. Is pag even ang nth root natin, pag even number ang nth root natin, the sign will become positive. But if our nth root is odd number, then our sign will become negative. So the limit of nth root of f of x as x approaches to c is equals to nth root of limit of f of x as x approaches to c is equals to nth root of L. Then let's start to our example. Example, the limit of square root of x squared plus 5 is as x approaches to 2. So we will just put our limit inside our radical sign, so it will become like this. Limit of x squared as x approaches to 2 plus 5. Bakit naging 5 lang to? Kasi paghihiwalayin natin yung dalawang limit na yan, yung limit ng x squared at yung limit ng 5. Kaya naging 5 lang to kasi ginamitan ng theorem number 1, which is kung ano yung constant natin, ayun na yung limit natin. Next step is kukunin lang natin yung value nito. Kaya siya magiging 2 raised to 2 kasi kung saan nag-a-approach yung x natin, ayun na yung magiging limit natin. So 2 raised to 2 plus 5, it will become 9. So what is the square root of 9? The square root of 9 is 3. That's it.